Bismillahirrahmanirrahim. I am Dr. Muhammad Ajmal with another lecture of the course of Applied Chemistry, having course code of CHEM3118. The topic of this lecture is water treatment for industrial purpose. The key concepts which will be covered in this lecture are industrial waste and wastewater, important contaminants in industrial waste, characteristics of industrial waste, and then common types of wastewater treatment methods. First of all, let's see what's industrial waste and wastewater. The industrial wastes include liquids, solids, and gases. The liquid part is commonly known as industrial wastewater. This wastewater is generated as a byproduct from process unit operation and have constituents which can cause harmful and hazardous effect to human, animal, plants, aquatic and microbial life, and also different life forms on the earth as well. Actually, industries use water that obtained from the water treatment system for a variety of purposes, such as for manufacturing of goods, for heating, for cooling, as carrier of raw material, as carrier of waste material, as a solvent, and the resulting water is then classified as a wastewater. The indiscriminate discharge of these wastewater streams into the environment can render soils sick. It means that can affect on the fertility of the soil as well. It can pollute the receiving bodies of water, and it can also cause air pollution by generating some obnoxious gases. The discharge untreated wastewater into the domestic sewage system makes the task of treating domestic sewage a very difficult and costly exercise. To prevent any health hazards caused by discharging wastewater into the environment and protect domestic sewage, the wastewater must be treated before discharge. The important contaminants of concern in wastewater treatment means वो कौन से इम्पोर्टेंट चीज़ें हैं जो वाटर में मौजूद होती हैं जिसकी वजह से हम उस वाटर को वेस्ट वाटर कहते हैं और फिर उन चीज़ों की रिमूवल इसमें से ज़रूरी है. The first one is suspended solid. These suspended solids are actually any material, any solid particle which remains suspended inside the water. These suspended solids lead to the development of sludge deposits and anaerobic conditions when untreated wastewater is discharged into the aquatic environment. The second important contaminants are the nutrients, which include phosphorus, nitrogen, and carbon. When these are discharged into the aquatic environment, these nutrients can lead to the growth of undesirable aquatic life. When discharged in excessive amounts on land, they can also lead to the pollution of groundwater as well. The third important contaminant in the polluted water or in the wastewater are the organic, which are named as priority pollutants, and these are organic and inorganic compounds selected on the basis of their known or suspected carcinogenicity or high acute toxicity. Many of these compounds are found in wastewater, which is obtained from different industries. Refractory organics. These are another important class of the pollutants present in the wastewater. These organics tend to resist conventional methods of wastewater treatment. Typical examples include surfactants, phenols, and agricultural pesticides. Heavy metals are also another important factor which cause water pollution, and these may be present in the water from different industries. So heavy metals are usually discharged to wastewater from commercial and industrial activities and have to be removed if the wastewater is to be reused. Dissolved inorganics. Inorganic constituents such as calcium, sodium, and sulfate are added to original domestic water supply as a result of water use and may have to be removed if the wastewater is to be reused. Characteristics of industrial wastewater. First of all, physical characteristics. Among the physical characteristics, the first one is the total solids. Let's see what's meant by the total solids. Analytically, the total solids content of wastewater is defined as all the matter that remains as residue upon evaporation at 103 to 105 degrees centigrade. It means when the temperature of the water or when the temperature of the wastewater is raised to 103 to 105 degrees centigrade, and then if still there is something that remains as residue in that water, then that is named as total solids. These total solids may be composed of floating matter, settlable matter, colloidal matter, or matter in solution. A classification of the total solids is also shown in this figure, where the total solids can be subdivided first into total suspended solids and into total dissolved solids. These total dissolved solids may be further of two types, which are volatile and fixed, while the total suspended solids can be further divided into two types. The first one is non-settlable and the second one is settlable. The non-settlable can further be divided into two types. One of them is volatile and the second one is the fixed. Similarly, the settlable can also be further subdivided into two types, same, the volatile and fixed. Another physical characteristic of the wastewater is odor. Odor, or mean you can say smell. Industrial wastewater may contain either odorous compounds, means the compounds due to which water may have some bad smell, or compounds that produce odor during the process of wastewater treatment. Temperature is another physical characteristic of water. The temperature of water is a very important parameter because of its effect on chemical reactions and reaction rates in treatment process and aquatic life. The temperature of the wastewater from different industries may be different from the water that is used for different domestic purposes, or that is also required for the living organisms, or the organisms which reside in water. Next physical characteristic is color. Color of industrial wastewater varies according to type of industry, and from industry to industry there could be different color of the wastewater, and it further depends upon the different pollutants which are actually present in the water. Mostly the colored matter is in dissolved state, just like different dyes. When these dyes are added in water, then these dyes are completely dissolved in water. The next physical characteristic of water is wastewater is turbidity, which is the measure of the light transmitting properties of water, and it actually depends on the colloidal and residual suspended matter inside the water. This is actually a test used to indicate the quality of wastewater discharge and natural waters with respect to colloidal and residual suspended matter. And now the chemical characteristics of the wastewater. Among the chemical characteristics, first one is the organic matter. It means the organic matters can be present inside the wastewater as an impurity or as a waste. And the presence of these organic matter complicate the industrial wastewater treatment because many of them either cannot be or very slowly decomposed biologically. Typical examples of the organic matter which may be present in the wastewater are fats, oils, grease, surfactants, phenols, volatile organic compounds, pesticides, and other agricultural chemicals. Some important parameters related to organic contents are biological oxygen demand and chemical oxygen demand. The biological oxygen demand is abbreviated as BOD. The determination of the BOD involves the measurement of the dissolved oxygen used by microorganisms in the biochemical oxidation of organic matter, while the chemical oxidation demand, that is abbreviated as COD, it oxidizes organic matter through a reaction with a mixture of chromic and sulfuric acid at high temperatures. The COD of water is in general higher than the BOD because more compounds can be chemically oxidized than can be biologically oxidized. And COD can be very useful because it can be determined in 3 hours as compared to BOD, which takes 5 days for its determination. And now the inorganic matter. The inorganic examples of inorganic matter which can be present in the wastewater are nitrogen and phosphorus, sulfur, and heavy metals. It means the wastewater may also contain inorganic matters. The third characteristic of the wastewater is biological characteristics. Some industries have certain pathogenic organisms like slaughterhouses, and some other industries have molds and fungi such as starch and yeast factories. This biological information is needed to assess the degree of treatment of the wastewater before its discharge to the environment, because it's necessary to assess that up to what content these biological uh, organisms are present inside the wastewater and how long or how much treatment is required. And now let's move towards some common types of wastewater treatment methods. The first one is physical unit operations. Treatment methods in which the application of physical forces predominates are known as physical unit operations, and these physical units operations include screening, mixing, flocculation, sedimentation, flotation, filtration, and gas transfer. The second type of the wastewater treatment methods are chemical unit processes. These are the treatment methods in which the removal or conversion of contaminants is brought about by the addition of chemicals or by other chemical reactions. Precipitation, adsorption, and disinfection are the most common examples used in wastewater treatment. Biological unit processes can also be used for the wastewater treatment. Treatment methods in which the removal of contaminants is brought about by any type of biological activity, those are named as biological unit processes. Biological treatment is used primarily to remove the biodegradable organic substances. These may be colloidal dissolved and nutrients such as nitrogen and phosphorus from wastewater. Basically, these substances are converted into gases and can escape to the atmosphere and into biological cell tissue, and finally can be removed by settling. Mechanical processes. Among the mechanical processes, the first one is screening. The first unit operation encountered in wastewater treatment plants is screening. A screen is a device with openings generally of uniform size that is used to retain the coarse solid found in the wastewater. Coarse solid mean the relatively large solid particles that are present inside the wastewater treatment. The process of screening is shown in this figure, which is also explained in the next slide as well. According to the method of cleaning, screens are designated as hand cleaned or mechanically cleaned, This left side figure is representing a hand cleaned, and the right side figure is representing a mechanical screen. In mechanical screen, there is a chain scraper which collects the raw material, or which collects these coarse particles or relatively large solid particles in it, and it rotates, and during this rotation it collects the large solid particles and water is moved through it. And the other one, which is manually, is also shown over here. It's just like a bar screen, and according to the size of openings, screens are designated as coarse or fine. Coarse mean these may be of large openings, and fine mean these may be very small openings. So coarse screens have openings of about 1.4 inch or more. It means the distance between the two successive bars will be 1.4 inches or more. And fine screens have openings of less than 1.4 inches. It means the distance between two consecutive uh, bars will be less than 1.4 inches. Another mechanical process that is involved in the treatment of wastewater is oil separation, uh, which is actually a process in which the floatables, which are mostly named as non-emulsified oil and organics, are separated out from the wastewater. There are two most commonly used separators for the oil separation. The first one is American Petroleum Institute separators. They are also named as API separators as well. The design of the separator is based on the specific gravity difference between the oil and the wastewater, and between the suspended solids and the wastewater. It means this is a process in which the suspended solid particles and the oil is removed out from the wastewater simultaneously. In general, this separator, that means American Petroleum Institute separator, can handle very large flow. It means a large amount of water can be added in it at the same time, but it has also a disadvantage that it takes long retention time that is required for efficient oil separation. Uh, a conventional API separator is shown in this figure, where from the inlet, from the left side as shown in this figure, raw water is added or wastewater is added, and sufficient time is given in this uh, tank to settle down the particles, the solid particles, and to float the oil particles or non-emulsified particles. And this oil is then collected in a pipe which is adjusted on the surface of this tank, and then this oil is sucked out from this pipe. The second type of separators are CPI separators, or these are also named as corrugated plate interceptors. They consist of stacks of plates or bundles of slanted tubes which are usually at 60 degrees in a vessel or a tank. As shown in this figure as well, these black lines are representing the slanted tubes which are arranged at an angle of 90 degree with the walls of the tank or walls of this vessel in which these are adjusted. It has been found that if the plates are tilted at 60 degrees, the solids will slide down the plates and can be collected at the bottom. Therefore, an angle of 60 degree has been suggested for these separators. A CPI unit can be placed in a small space but cannot take shock loads and high flows. So this can be a drawback of this separator as well. However, they are usually more efficient than API separators and primary clarifiers in removing oil and solids, as more surface area can be provided in these tanks. The role or the action of this tank is also quite similar to the American separator. Here the solid particles are separated from the water with relatively high speed, because we have some slanted tubes or plates from which solid particles are dropped down and then they are settled down over here. The oil is collected above the surface, and from the surface it is collected in a pipe and then sucked out from this pipe uh, to remove out from the wastewater. The third mechanical process that is involved in wastewater treatment is flow equalization. Flow equalization is a process of mitigating the changes in flow rate through a portion of a system by providing storage to hold water when it's arriving too rapidly, and to supply additional water when it's arriving less rapidly than desired. इट मीन ये कोई एक एक्स्ट्रा टैंक आप कह सकते हैं कि वो अटैच होता है। उस एक्स्ट्रा टैंक में कुछ अमाउंट ऑफ वाटर मौजूद होती है कि जब रेगुलर जो एक वाटर का फ्लो आ रहा है, अगर वो रेगुलर फ्लो में पहले रेट ऑफ फ्लो में अगर डिक्रीज आती है, यानी ऊपर से एक टैंक से दूसरे टैंक में वाटर कम पहुंचता है, तो वाटर की क्वांटिटी को पूरा करने के लिए यहाँ से इस एक्स्ट्रा टैंक से वाटर उस फ्लो में ऐड किया जा सकता है। या फिर ये भी होता है कि एक टैंक से दूसरे टैंक में जब वाटर ट्रांसफ़र कर रहा है वेस्ट वाटर ड्यूरिंग ट्रीटमेंट, तो उसकी अमाउंट ज़्यादा हो सकती है। अब एक टैंक से दूसरे टैंक में जब अमाउंट ज़्यादा जा रही है वाटर की और अगले टैंक की वाटर को रिटेन करने की कैपेसिटी कम है, तो फिर यहाँ पर भी हमें वाटर के फ्लो रेट को कंट्रोल करना है। तो इस कंडीशन में ये जो एक्स्ट्रा टैंक है वो एक्स्ट्रा अमाउंट ऑफ वाटर को अपने अंदर स्टोर कर सकता है। सो ये एक ऐसा मटेरियल है जिसके ज़रिए फ्लो इक्वलाइजेशन की जाती है। एंड इन मैनी वाटर ट्रीटमेंट सिस्टम्स it is useful to implement flow equalization downstream of the plant, because the downstream demand is not steady, but in general the treatment processes work more efficiently if the flow rate through them is steady. इट मीन स्टीडी फ्लो रेट को मेंटेन रखने के लिए हमें मोस्टली फ्लो इक्वलाइजर्स यूज़ करने पड़ते हैं, जबकि नॉर्मल जो वाटर ट्रीटमेंट का प्रोसेस है उसमें ये होता है, ये डाउनस्ट्रीम डिमांड इज़ नॉट स्टीडी। यहाँ पर इसका मतलब ये है कि जब हम वाटर को एक टैंक से दूसरे टैंक में ट्रांसफ़र कर रहे हैं, तो वहाँ पर जो इसका जो ट्रांसफ़र है दिस इज़ नोन एज डाउनस्ट्रीम। और ये जो डाउनस्ट्रीम का जो रेट है ये इन प्रोसेसेस में मोस्टली डिस्टर्ब होता रहता है, वो कांस्टेंट नहीं होता। लेकिन अगर ये कांस्टेंट हो तो फिर हम मोर एफिशिएंट वो जो डिवाइस होगा वो मोर एफिशिएंटली वर्क कर सकता है। सो उसकी एफिशिएंसी को इन्हांस करने के लिए या मेंटेन रखने के लिए ये फ्लो इक्वलाइजर्स यूज़ किए जाते हैं। And the design must provide for sufficient mixing. Design of these flow equalizers must provide for sufficient mixing to prevent solids deposition and concentration variations, and also to provide aeration to prevent odor problems. It means इसको इस तरह का बनाना चाहिए, इसका डिज़ाइन ऐसा होना चाहिए कि ना तो फ्लो इक्वलाइजर्स जो हैं इनमें सॉलिड्स की डेपोजिशन भी नहीं होनी चाहिए, और ना ही इनकी वजह से कोई स्मेल उसके अंदर जनरेट होनी चाहिए, और ना ही ऐसा होना चाहिए कि इम्प्योरिटीज़ की जो कंसंट्रेशन है वो इन्हांस हो जाए। सो ये सारे पैरामीटर्स को मेंटेन रखा जाता है इस फ्लो इक्वलाइज़र के अंदर। And the best location for equalization facilities to be at existing and proposed treatment plant sites. In some cases, equalization after primary treatment and before biological treatment may be appropriate. And now the physical treatment processes which are involved in wastewater treatment. The first process of physical treatment is sedimentation. It means physical treatment can be carried out through sedimentation. The sedimentation is the separation from water of suspended particles that are heavier than water by gravitational settling. And these suspended particles, which are separated out from water in sedimentation, may be of any liquid other than water, or maybe any solid material that is suspended in the water. The sedimentation is used for separation of grit and particulate matter in primary settling basin. This is also used in separation of biological floc in activated sludge settling basin, and also used in the separation of chemical floc when the chemical coagulation process is used. And it's also used for solid concentration in sludge thickeners. यहाँ पर जो हमने बात की है कि grit and particulate matter, then grit, these are grit is actually solid particles like sand or other similar particles, and biological floc mean the group of bacteria, and chemical floc mean the group of small chemical molecules or any chemical species except water that is present inside the water. Sedimentation basins are constructed in a variety of shapes and sizes. These may be circular tanks or these may be rectangular tanks. And the basins, each basin is comprised of 4 zones according to their function. The first zone is inlet zone. The second zone is settling zone. The third one is sludge zone, and the fourth one is the outlet zone. These are also demonstrated in these figures as well. And if we talk about their actions, then the inlet zone is a region where the incoming suspension is distributed uniformly over the cross section of the tank. ओवर द क्रॉस सेक्शन ऑफ द टैंक का मतलब अब यह है कि टैंक की जितनी भी वो सरफेस बनती है ऊपर, ये उस सरफेस पे इनकमिंग सस्पेंशन को ऑलमोस्ट यूनिफॉर्मली या इक्वली डिस्ट्रीब्यूट करता है. दिस इज द रोल ऑफ इनलेट जोन. The next is the settling zone, as shown in this figure. In the center of this there is a settling zone. In the settling zone, the particles settle at the same rate as they would be in quiescent. That means they will be settled without any noise. Slowly they are settled down. The third one is the outlet zone. In this outlet zone, the clarified liquid is collected uniformly over the cross section of the basin. The solids collect in a sludge zone at the bottom of the tank. So this is the fourth one, or the role of the sludge zone is to collect the solid which is settled down. Sedimentation basins are constructed in a variety of shapes. These may be circular tanks or these may be rectangular tanks. Here is a diagrammatic representation which is demonstrating the role of each portion of these tanks, and here are the pictures from the original plants of the rectangular basin and the circular basin. The physical treatment of wastewater can also be carried out by another process that is known as flotation. This flotation is a unit operation used to separate solid or liquid particles from a liquid phase. In flotation, the separation is brought about by introducing a fine gas, usually air bubbles, into the liquid phase. These air bubbles then attach to the particulate matter, and the buoyant force of the combined particle and the gas bubble is great enough to cause the particles to rise to the surface to form a scum blanket, which is removed by a skimming mechanism. Grit and other heavy solids that settle to the bottom or react to a central sludge for removal. It means जो स्लेट या दूसरे हैवी सॉलिड्स होते हैं जो इजीली सेटल डाउन हो जाते हैं, वो इस प्रोसेस से पहले उनको किसी और मेथड्स के साथ सेपरेट कर दिया जाता है. यहाँ पर हमने बात की है बॉयंट फोर्स की. लेट्स सी कि ये बॉयंट फोर्स क्या है. Buoyant force जो है, this is actually an upward force exerted by a fluid that opposes the weight of a partially or fully immersed object. As shown in this figure, there are two particles. One of them is floating at the surface and the other one is almost present or completely dipped, or we can say that's present as a sink, in the sink. And these particles are being pushed in upward direction by the liquid due to the kinetic force of the liquid. So this upward force is known as buoyant force. This upward force pull the particles toward the surface, and from the surface these are separated out. So this is the process of flotation. The flotation process can further be divided into two types. The first one is air flotation and the second one is vacuum flotation. In air flotation, air bubbles are formed by introducing the gas phase directly into the liquid phase through a revolving impeller through diffusers, as shown in this figure. अब ये जो फिगर है इसमें ये सेंटर में जो एरोज शो कर रहे हैं, this is representing a revolving impeller. अब इसमें गैस एंटर होती है और ये उस गैस को रिवॉल्व करता है. रिवॉल्व करने के बाद जो है ये उस लिक्विड में बबल्स की फॉर्म में एंटर होती है एंड देन इट स्टार्ट्स टू राइज अप इन द लिक्विड. और ये जो गैस बबल्स हैं, ये गैस बबल्स फिर उस लिक्विड पार्टिकल में जो सस्पेंडेड पार्टिकल्स, लिक्विड मीडियम में यानी वाटर में जो सस्पेंडेड पार्टिकल्स हैं वो लिक्विड के हों या सॉलिड के हों, ये उनके साथ अटैच होते हैं और जो बॉइंग फोर्स है या फिर इनका जो बबल्स हैं ये फिर अपवर्ड डायरेक्शन में मूव करते हैं एंड देन फ्रॉम द सरफेस दे आर कलेक्टेड आउट. द सेकेंड टाइप ऑफ फ्लोटेशन सिस्टम इज वैक्यूम फ्लोटेशन. This process consists of saturating the wastewater with an air either directly in the aeration tank or by permitting air to enter on the suction side of the sewage pump. एक इसमें एग्जाम्पल यहाँ पर दी हुई है कि यहाँ पर एक एयर कॉन्टैक्ट टैंक है. यहाँ से एयर को एक प्रेशर के ज़रिए इस दूसरे टैंक में ट्रांसफ़र किया जा रहा है और यहाँ पे इस एयर को इस तरह से उसके अंदर एंटर करते हैं कि ये बबल्स की फॉर्म में उसके अंदर जाके बबल्स की फॉर्म में कन्वर्ट होती है और ये बबल्स फिर राइज अप होते हैं एंड देन द सेम प्रोसेस एज वी हैव डिस्कस्ड इन द प्रीवियस स्लाइड कि ये बबल्स जो हैं ये सॉलिड या लिक्विड सस्पेंडेड पार्टिकल्स के साथ अटैच होते हैं. फिर बॉयंट फोर्स जो है अगेंस्ट दी बबल्स एंड अगेंस्ट दो सॉलिड पार्टिकल्स वो इनको upward push करती है और above the from the surface these are collected out. The solid particles are collected out from the surface. And now the chemical treatment of wastewater. There are different methods which involve the chemical treatment. First one is neutralization. Industrial wastes often contain acidic or alkaline components which require neutralization before discharge or treatment. For wastes that are discharged to receiving waters, a pH between 6 and 9 is frequently specified by regulatory agencies. For wastes entering biological treatment processes, the pH should be maintained between 6.5 and 9 for optimum growth of the microorganisms. It means कि इंडस्ट्री से जो वाटर आ रहा है, जो वेस्ट वाटर आ रहा है, तो सबसे पहले हमने उसकी पीएच को चेक करना है. अगर उसकी पीएच 6 से 9 की रेंज में नहीं है देन वी हैव टू एडजस्ट इट्स पीएच. और ये जो पीएच की एडजस्टमेंट है ये हम कर सकते हैं बाय द प्रोसेस ऑफ न्यूट्रलाइजेशन. न्यूट्रलाइजेशन में ये है कि अगर एसिड की हमें ज़रूरत पड़ती है तो हम उसमें एसिड ऐड कर सकते हैं, अगर बेस की ज़रूरत पड़ती है तो हम बेस को ऐड कर सकते हैं. सो एसिडिक वेस्ट्स आर कॉमनली न्यूट्रलाइज्ड with waste alkaline streams. These waste alkaline streams may contain lime, dolomite, ammonia, caustic soda और soda ash. जो एसिडिक वेस्ट्स हैं उनमें हम कोई बेसिक मटेरियल्स या अल्कलाइन मटेरियल्स ऐड करते हैं तो उनकी पीएच को हम मेंटेन कर लेते हैं। और ये जितने यूज़ हो रहे हैं इनमें से जो लाइम है दैट्स मोस्ट वाइडली यूज्ड अल्केलाइन मटेरियल फॉर न्यूट्रलाइजेशन ऑफ एसिड वेस्ट्स बिकॉज ऑफ इट्स लो कॉस्ट। Lime may be slow to react and may form insoluble precipitates as well. Alkaline wastes को कैसे करते हैं? Alkaline wastes usually require treatment with waste acid extreme, and these acid extreme may contain sulfuric acid or hydrochloric acid. Among the chemical treatment, another method is of oxidation or reduction. This is sometimes combined named as redox treatment or redox method as well. Oxidants are used in wastewater treatments as a first step in the removal of heavy metals to oxidize organics, or as a last step in a treatment process to oxidize odoriferous compounds. Odoriferous compounds mean the compounds which have some sort of bad smells, such as hydrogen sulfide, which has a bad smell. And these can also be added to oxidize inorganics, such as cyanide, and for disinfection as well. Some common oxidizing agents or oxidation agents used in wastewater treatment are oxygen, chlorine, sodium hypochlorite, potassium permanganate, sodium calcium hypochlorite, and hydrogen peroxide. The chemical treatment is also carried out by chemical precipitation method. The chemical precipitation in wastewater treatment involves the addition of chemicals to alter the physical state of dissolved and suspended solids and facilitate their removal by sedimentation. It means हम कोई ऐसा केमिकल उस वाटर में या वेस्ट वाटर में ऐड करते हैं जो उस वाटर में मौजूद इम्प्योरिटीज़ के साथ जाके रिएक्ट करता है, यानी एक केमिकल प्रोसेस हो गया, और उस रिएक्शन के रिजल्ट में प्रेसिपिटेट्स बन जाते हैं और वो प्रेसिपिटेट्स वहाँ पर सेटल डाउन हो जाते हैं। अब जिस टैंक में या जिस भी पार्ट में, जिस वेसल में हम ये प्रोसेस कर रहे होते हैं, उस वेसल के या उस टैंक के बॉटम पे इन प्रेसिपिटेट्स को कलेक्ट कर लिया जाता है। कुछ टाइम दे देते हैं कि जो प्रेसिपिटेट्स हैं वो वहाँ पर सेटल डाउन हो जाएं। जब प्रेसिपिटेट्स सेटल डाउन हो जाएंगे तो उन प्रेसिपिटेट्स में एक्चुअली वो इम्प्योरिटीज़ शामिल हैं जो उस वाटर में मौजूद हो के उसको वेस्ट वाटर बना रही हैं। सो इस तरह केमिकल प्रेसिपिटेशन के ज़रिए उनको वहाँ से सेपरेट आउट किया जा सकता है। जैसे कि इस फिगर में भी इसको डिमॉन्स्ट्रेट किया गया है that a contaminated or wastewater is containing some impurities, and then a coagulant or any precipitating agent is added in this water. Then this precipitating agent combined with these impurities and convert them into a material which can be easily settled down. These precipitates are then settled down as impurities, and rest of the water is removed out from here. Chemical precipitation can be carried out either by coagulation or can also be carried out by flocculation. What happens in the coagulation? Coagulation takes place in rapid mix or flash mix basins, which are very rapid. The primary function of rapid mix basin is to disperse the coagulant so that it contacts all the wastewater. It means एक बेसन में हम केमिकल अपना ऐड करते हैं जिस केमिकल ने प्रेसिपिटेट्स बनाने हैं, और उस केमिकल की एडिशन के फौरी बाद उसको बहुत हाई स्पीड के साथ स्टीरिंग की जाती है, जो उसको उसके अंदर रोटेट किया जाता है ताकि जितना भी एरिया है वाटर का उस सारे एरिया में ये कोआगुलेंट या ये वाला जो केमिकल है ये डिस्पर्स हो जाए, ताकि उस वाटर के जिस जिस एरिया में भी कोई इम्प्योरिटी मौजूद है ये उसके साथ कांटेक्ट कर सके, और कांटेक्ट करने के बाद उसको प्रेसिपिटेट में कन्वर्ट कर सके, और फिर ही वो जब वो प्रेसिपिटेट्स बनेंगे तब ही उनको हम सेटल डाउन कर सकते हैं या वो सेटल डाउन हो सकते हैं। और जो बहुत कॉमन यूज़ किए गए हैं बहुत कई सालों से कोगुलेंट मटेरियल्स या प्रेसिपिटेटिंग मटेरियल्स, वो हैं एलम, फेरस सल्फेट, लाइम, कैल्शियम हाइड्रोक्साइड जिसको हम कहते हैं, फेरिक क्लोराइड एंड फेरिक सल्फेट। द सेकंड मेथड यहाँ पर जो केमिकल प्रेसिपिटेशन में यूज़ होता है, दैट इज़ फ्लूकोलेशन। The purpose of flocculation is to form aggregates or flocks from the finely divided matter. It means जो suspended particles हैं solid के हैं या liquid के हैं वेस्ट वाटर में, फ्लोकुलेशन में ये होता है कि उन सस्पेंडेड पार्टिकल्स को आपस में एक दूसरे के साथ कंबाइन कराया जाता है। वो कंबाइन होके लार्ज पार्टिकल्स में कन्वर्ट होते हैं और वो लार्ज पार्टिकल्स जो हैं अपनी ग्रेविटेशनल फोर्स की वजह से सेटल डाउन हो जाते हैं। जब वो सेटल डाउन हो जाते हैं तो वहाँ से उनको सेपरेट कर दिया जाता है। फ्लोकुलेशन ऑफ वेस्ट वाटर बाई कैन आल्सो बी कैरिड आउट बाई मैकेनिकल और एयर एजिटेशन। Here is the demonstration of chemical separation with the help of a figure, which is representing that raw water is first added into a tank and a coagulant is also added in the same tank and flash mixing is done. Flash mixing means the coagulant is stirred so that it come in contact almost with every part of water or almost with every suspended impurity in the water. Then this is transferred into the flocculation basin. In flocculation basin, first of all, it is stirred at very high speed. Then gradually the steering speed is decreased from high speed to medium speed, and then from medium speed to the low speed. And when we reach to at very low speed, then the flocculated or the coagulated particles are settled down, and then these settled down particles are separated out from this part of the reactor. This chemical precipitation is being used for improving plant performance. Let's see why these are being used. These are being used for the improvement of plant performance. If we use the chemical precipitation, then from 80 to 90% of the total suspended matter and 50 to 80% of the BOD and 80 to 90% of bacteria can be removed by chemical precipitation. In comparison, when plain sedimentation is used, only 50 to 70% of the total suspended matter, 25 to 40% of BOD and 25 to 75% of bacteria can be removed. It means ये जो chemical precipitation method है, this is very effective or very efficient as compared to the other conventional or other plain sedimentation method. क्योंकि यहाँ पर जो suspended matter है वो हम 80 to 90% तक remove कर सकते हैं, जबकि जो plain sedimentation method हम use करते हैं वहाँ 80 to 90 की बजाय हम 50 to 70 यानी मैक्सिमम 70% तक इनकी रिमूवल हम कर सकते हैं। सिमिलरली जो BOD है, BOD को केमिकल प्रोसेस के ज़रिए हम 50 to 80% तक इसकी रिमूवल हो सकती है, जबकि जो प्लेन सेडिमेंटेशन है वहाँ पर ओनली 25 to 40%, यानी ऑलमोस्ट हाफ है कि वहाँ 40% मैक्सिमम है, और इन केमिकल प्रोसेस we can reach towards 80%. And same in case of bacteria, कि बैक्टीरिया का जो है केमिकल कंपोजिशन में हम 80 to 90% जो बैक्टीरियाज हैं उनको हम रिमूव कर सकते हैं केमिकल प्रेसिपिटेशन से, जबकि जो दूसरे मेथड्स हैं जैसे प्लेन सेडिमेंटेशन है उससे हम सिर्फ 25 to 75 यानी मैक्सिमम 75% बैक्टीरिया को रिमूव कर सकते हैं. So this is the advantage of chemical precipitation method over other conventional methods for the treatment of wastewater. And this is an assignment for the students. Students will have to study about flocculation and coagulation, and then design a comparison between flocculation and coagulation. In this comparison, they will have to differentiate these two terms, and they will have to provide any similarities between these two terms as well. That is the end of this lecture, but not the end of this topic. Rest of the topic will be completed in the next lecture.